Hello, everyone. Welcome to today's Blue Mission Atlantic and Arctic weekly hour. My name is Ana Faria. I'm a team member of the Blue Mission AA at the Air Center, and I'm very happy to welcome you all to this weekly hour, which will be entirely devoted to technological and digital innovation systems. It's going to be a full hour where several projects will showcase its innovative solutions for our common goal of monitoring, protecting, and conserving our ocean and waters. I'd like to introduce you to our moderator, Josipa Rapovic, if I'm correct. She's a project manager at F6S. And I'd like to thank you, Josipa, for putting this webinar together. It seems it's going to be a very exciting program to share with all of you. And I will give now the floor to you. Thank you.
Thank you, Anna. Just to say, yeah, welcome everyone. Thank you for joining. Thanks to our speakers also for being here, for introducing their projects. We are really thrilled to be co-organizing this session, F6S with the Blue Mission AA team. And thank you also to both Anna, Faria, and Patricia and the entire team for hosting us today. About the session, today in this session, we will explore how 6 different EU-funded projects are leveraging technology from AI and robotics to specialized sensors and digital twins in order to enhance the management and the protection of our oceans and waters, as Anna has said. Before we officially start, I want to do a brief housekeeping. Please note that we do have a quite tight schedule. Since there are 6 projects here, we have 10 minutes approximately allocated for each project showcase. So we do encourage you to submit your questions via the Q&A box. There is a chat box below. You can press it and put your questions there. And then we will have a dedicated session at the end of the presentations where we will address each and every one of the projects and the questions that you might have. Okay, also this session is being recorded and live streamed also on YouTube, so you can take a look at it later and also share it amongst your networks as well. Okay, so without further ado, I'll get straight into the project's showcases. First, our first speaker today is Ali Muhammad. He's a senior consultant and project management manager at TNO. He currently works as a lead technology expert at I-SEAMORE. His field of work involves systems engineering, requirements analysis, concept and system development of observational systems and multi-sensor data, as well as information fusion for decision-making. He worked on multi-sensor fusion and autonomous mission planning and execution for autonomous decision support for the Ministry of Defense and Homeland Security. And today he will be presenting his work and the work of the technological projects in the project of I-SEAMORE, which focuses on the integrated maritime surveillance leveraging UAVs. So Ali, please go ahead and share your presentation. Sorry, Ali, you are muted, so we didn't hear your beginning.
Yes, apologies for that. My name is Ali Mohammed at TNO Defense Safety and Security, a research and technology organization from the Netherlands. Today I will share with you the vision and insight and results from Project I-SEAMORE. So Project I-SEAMORE comes up with a ecosystem that facilitates the end users to optimize their operational excellence. The project, the ecosystem of I-SEAMORE, combines the currently existing legacy systems, the coastal surveillance systems, but it also adds additional innovations, combining the use of USVs and unmanned systems, aerial unmanned systems. The concept also facilitates use of satellite data, utilizing Copernicus data. It combines all these assets, unmanned systems. It combines with manned systems, such that the operational centers of end users can optimize their operational excellence, as I mentioned. So the I-SEAMORE project's vision uses a kind of iterative approach, which starts with the definition of end user needs, translate that into operational requirements and system requirements. That avoids ending up a system that does not match the requirements of end users. So based on the definition and the engagement with the end users, we come up with a system architecture that is shared, that is common among the technical partners, but also end users involved within the project and end users that are relevant, but that are not in the project. We start with an iterative development phase where we combine the innovations in unmanned systems. For example, a key requirement is the improvement of the endurance of these systems. It's very important for maritime surveillance system. There are also tools which we innovate in the project, which are data fusion services. So we combine these two elements based on the engagement with end users, develop these components and integrate them into what we call I-SEAMORE ecosystem. And that integration and testing is a process as such that we use what we call testing cycles. What it means is that we combine the technological developments with the end user engagements where we refine the system based on the results from the testing and integration results, and go back to the definition phase and update also the system architecture. That allows us to provide the demonstration, if you like, the demonstration process, a qualified system. So the project concept covers much of the relevant use cases in the maritime security operations. You see at the right-hand side a number of very relevant use cases, very familiar: drug smuggling, irregular migration, goods smuggling, piracy, terrorist attacks, all those aspects. The two use cases at the left-hand side, light blue, drug smuggling, irregular migration, the use cases the project chose to do the trials. What that means is that a very close engagement with end users led to the selection of these two use cases. Why? Because these two use cases are very relevant for the involved end users, and it's one of the challenges that we are facing in the continent. So the drug smuggling use case, we have discussions with the end users, both from the North Sea, the UK Border Force, and in the southern part end users, the Portuguese Navy, Spanish end users, and we came up with a collective, a very relevant drug smuggling use case. The irregular immigration is also the same approach. We use the same approach based on real-world detected usual migration corridors. And these two use cases have been used within that ecosystem development, engaging with the end users, to start with the end users and define requirements to functionalities and an ecosystem that answers the needs of the end users involved. Now I will give you some very short example of how that iterative methodology worked. So what we have done is the multi-step development I've just mentioned. We have put that into practice. How did we do that? We've used a modeling and simulation environment where we create the scenarios and check that with the end users. We validate the scenario space using the simulation model. We also use the simulation model in order to generate stimuli input for the ecosystem we are developing, such that we are able to verify the system. And that iterative process has been also used to generate relevant data based on the end user experience. We have used also what we call orchestration platform within the project, which means a capability that provides computation, storage, and network capability where we can configure different configurations of the systems and tools. We've used two different orchestration platforms so that we can mitigate any eventualities if things go wrong. At the right-hand side, you see the test cycles where the end users and technical partners get together, test the system, and iterate and improve the system. That has enabled us to come up with a number of configurations based on the use case, which I have already mentioned, and the available data and available unmanned systems, but also manned systems. And the combination of those two things enabled us to come up with rehearsal practices, which gave, at the end of the day, configurations which are ready to be validated within the demonstration of the project. So the demonstration of the project, we have co-hosted the demonstration of project during the REPMS 25. That is the biggest NATO naval unmanned systems exercise in Portugal, and the Portuguese Navy was a part of the project, so that was very feasible to do. So the main we have focused within the maritime, within the I-SEAMORE projects, the maritime safety and security, and capabilities we have provided for these scenarios is object assessment capabilities, surveillance, coverage, tracking, and track-to-track fusion, anomaly and behavior analysis, but also mission planning support, the tasking of unmanned systems in line with the needs of the end users. A number of end users were involved. As I mentioned, the Portuguese Navy, UK Border Force, from Spain and Romania. The data we have used within the I-SEAMORE demonstration trial was the coastal surveillance systems, the current legacy systems, but also added innovative data, for example, from the unmanned systems, both aerial and surface unmanned systems, and we also include high resolution data from the satellites. So just to give you an example of the operational trial and the assets, based on the use case we have already mentioned, we have assigned for each use case a number of assets which are very relevant for mimicking the real behavior of, for example, a drug smuggling use case where two vessels in the North Sea, you have a fishing vessel approaching a merchant vessel. In the southern part of the continent, you have a merchant vessel approached by a speedboat. So we combined all those features, if you like. So we had an authority vessel provided by Spanish end user, and we have a number of vessels from the Portuguese Navy mimicking, for example, the merchant vessel or the fishing vessel. At the lower part of the picture, you see the number of real assets, unmanned assets we've used, the long-range Primoca UAV, the medium-range VT-1 from Portuguese Navy, and the Excel USV. And this, the funny thing, the most important thing is that the VT-1 has been added very recently to the project. So the interoperability capability of I-SEAMORE concept has been proved by connecting this asset very easily to the system, to the ecosystem of the I-SEAMORE. You see here screen captures from the I-SEAMORE trial demonstration where we have combined the use of unmanned assets, tasking from the mission command from I-SEAMORE, using the data to analyze and detect any potential anomalies, and using the data fusions to generate behavior analysis, what's normal, what's not normal, and the anomalous behavior of certain vessels. You see here two different use cases. One is the drug smuggling at the right, this side, where the system captured the behavior, the potential behavior of drug smuggling use case. At the right hand side, you see the drone capture from the air. We tasked to capture the irregular migration mimicking vessels. So in a nutshell, and I know the time is very short, this what we have seen through the approach we have chosen, iterative approach and engagement of end users, ends up with a project result, which is I-SEAMORE ecosystem that's capable of answering the questions or the end user needs, which we translate into operational requirements. So this, the trial was successful. The two use cases have been very relevant, and the system has captured what has been necessary to capture. We are currently processing all the data we have received, especially from the feedback from end users and other external stakeholders, and we translate that into next actions beyond the project. At this moment, we are also doing the exploitation of certain products of the project. We are some technical providers are already engaged in maturing their products. In other cases, we are already thinking about joint development activities from the I-SEAMORE ecosystem level, but also certain products within the I-SEAMORE system are currently being ready for business opportunities. I thank you.
Thank you, Ali, for your lovely presentation on the I-SEAMORE operational trial demonstration, and also for the successful execution of the I-SEAMORE system. If there's any questions for Ali and for his presentation, feel free to use the chat box there on the bottom of your screen and pose your questions there, and we will answer them in the dedicated session at the end of today's webinar. Next, we have Evangelos Boukas. He's a project coordinator and associate professor at the Technical University in Denmark. He's specializing in perception and machine learning for robotics. He's the coordinator of AUTOASSESS project, and his research focuses on autonomous aerial inspection in confined and GNSS denied environments with applications across maritime and critical infrastructure. Prior to working at the Technical University of Denmark, he held positions at Aalborg University and Demokritos University of Thrace, contributing to international projects with organizations such as the European Space Agency and the UK's Defence Science and Technology Laboratory. He actively collaborates with industry partners and is committed to bridging academic research with real-world impact. And today he's going to give us a presentation on AUTOASSESS and AI and robotics for safe inspection in vessel inspection in dangerous areas. So Evangelos, the floor is yours.
When you put it like that, it sounds impressive, but all right, not really. So yes, I'm the coordinator of the AUTOASSESS project. I have a bit of an intro to the project and some current development. So the project is funded by EU, of course, and it's around 13 million euros, of which the 3 million is funded by Switzerland through their own means. We have 17 partners now because we just added ETH in Zurich. So this is a okay. So hopefully you cannot hear this. I hope you cannot hear this. So the point of the project is to be able to replace these surveyors that work in these dangerous areas, so inside the ballast tanks of ships. And the idea is that we replace the surveyors with robots. We have a set of robots that solve this solution. But before we go into all the details of the project, I want to just bring a little bit of motivation. So this is one of these videos that makes your heart stop because the ships are not supposed to be articulated. So this is a ship that failed in the middle of the Black Sea. It's an old ship and it failed because of lack of proper maintenance. So there were unfortunately casualties. There are also videos from the other ships, and you can see really how fast the ship goes down. So we want to avoid that. What are we trying to do why do we need to do the AUTOASSESS? We have a lot of issues with ship inspections and structural defects. We have delays because the ships need to go for dry dock. We have cost of repairs. We have loss of opportunity. But above all, we have risk of human life. So what do we want? We want to be able to have consistent reporting, to not have humans to decide whether a ship should be seaworthy or not, because humans are subjective. An old surveyor thinks that nothing will kill a ship, and a very new surveyor thinks that every single spot on a ship will make it fail. So we want to put robots that are objective. This is the environments we're working on. On the left, you see the cross-section of a bulk carrier. On the right, you see a cross-section of a tanker or a container ship. So this is the areas that we're working. We're working both in a cargo area, but also in the ballast tanks. These areas that are on the side of the vessel. So here is another way of looking at the project. We have the current status where surveyors go into these dangerous areas with ladders and lights, and it's not very good. That's why it's red on the left. And on the right is very green. It's amazing. It's our project. It's going to be fully autonomous. Drones are going to be flying in these environments and collecting information about the corrosion. The way that we solve this is that we involve 3 robots. We have 2 robots working in the ballast tanks and 1 robot working in the cargo holds. So the first robot, the exploration UAS, is a very small and fast robot that is able to fly through the environment without doing mapping or very complex observation of the area. It doesn't do inspection. But what it can do is it can collect all the images, and then we can, after it comes back, create a full map of the environment. Then we have the second robot, which is the inspection drone, that goes down the ballast tanks. Now it has a map, and it can plan specific areas to go and take measurements. So those 2 solve the problem of ballast tanks. And we have a third one, which is called the tether robot, tether UAS, which deals with the cargo hold. This is a robot that can fly for infinity because it is a robot with a tether. That means that the exploration and the inspection all happens at once. So if I look at it from a more systematic point of view, here on the left side, you see our user interface. Our robot is supposed to be fully autonomous. Therefore, we have a system that you can just say high-level command, do an inspection on ballast tank number 3 or whatever. And then it is also able to collect all the information from the drones and visualize them into a human-friendly way. That's also where the planning happens and all the things that are not running on the robot. Then we have these 2 drones, as I said, the exploration UAS and the inspection UAS that run on the ballast water tanks. And then we have this other robot that is working on the cargo holds. I'm not going to spend all the time, but we have several verticals of technology, robotic technologies, like navigation and path planning, control, localization, and machine learning for the inspection. And all of these are shared somehow by the different robots. So it's not that someone is developing in the project just for one robot. We're developing the technologies and we're applying it to different agents. Therefore, we have worked on the project for the last 21 months, so we do have some results to show. So here you can see our drones flying into this environment. So we have done a lot of data collection and a lot of annotation of corrosion and defects. We have gone both to early ships and older ships. Then we are able to run this kind of localization and mapping, so the robot knows where it is and can create a map of the environment. This has happened by the Technical University of Munich, and you can see some of the results here. So on the left, you see the view from the robot. On the right, you see the estimation of these 3D points in the ballast tanks. Again, remember, this all works without GPS. It has to be its own means. The robot is working on its own means. Finally, we have some exploration. So when we don't know the environment, we can just run the robot a little bit and figure out what the shape is. So here you see just the live creation of one of these environments. So now you can see how a tank looks like from the robot point of view. And we have also been working a lot with the inspection aspect, so to detect corrosion in the field of view of the images. So you can see here some of the things that we are running here at DDU. So this is the detection of different types of corrosion, and this has never been trained on this kind of images. It has been trained only on simulation and then tested on the real images. So if we look at the direction of the project for the next year, we really are going towards high level of autonomy for this for inspection. And we really try to do full inspection to classification pipeline. That means the robot goes in and we have already all the material when the robots go out to be able to say whether the ship is ship-worthy or not ship-worthy. And with that, thank you so much for being here, and if you have any questions.
Perfect. Thank you, Evangelos. Yeah, any questions that you might have, like I said, post them in the chat, and then we'll do a Q&A session at the end. Thank you so much for presenting and for being quite effectively on time. Our third presenter is Tjerk Krieger, project engineer at Morris. It's an organization specializing in marine data management. Tjerk holds a master's in hydraulic engineering, and today he will be doing a presentation on the project called Effective, about the reusable 3D digital twin framework for marine protected areas in the blue economy. Tjerk also holds a master's degree in hydraulic engineering from the Delft University of Technology. Thank you for being with us today, and yeah, the floor is yours, Tjerk.
Yeah, thanks, Josipa. So yeah, today I will indeed talk a bit about the Effective project, and I will zoom in on the three-dimensional digital twin that we are currently developing in the project, and see how we can actually reuse components from this twin also in other applications. So first, a bit about the Effective project. We are looking at 4 marine protected areas in the Mediterranean Sea. One near Barcelona, one near the Ebro Delta, one near the north of Sardinia, and we have one in Capo Greco. And at each of these marine protected areas, we are implementing innovative nature-based solutions, and we're also looking at different restoration actions. Next to this, we're applying an ecosystem-based management approach for each of these pilots specifically. If we then look at how the project is built up, we have 3 different blocks. So we have a policy frame that develops the governance in each of the MPAs and focuses on implementing the nature-based solutions at the pilots, and the information pillar, which is what we will focus in today, which is monitoring the restoration actions at the site and also looks at the digital twin. And then finally, we have the third block, which is on participation and communication, which is about stakeholder engagement. So if we zoom in on this second pillar, we have a task on the digital twin combined with citizen science and also spatiotemporal modeling. For the digital twin, we're looking at one map interface, which covers the whole Mediterranean, where we try to collect all local data, so the sensor data that the pilots are measuring, but also we combine it with model output as well as available human activity layers or physics layers that we find in general European aggregators. We have, for example, connectivity models that we are developing in the Effective project that looks at how different habitats are connected to one another and how, for example, the distribution of a certain coral type are within different ecosystems. And then we also have some citizen science activities at the different sites where we try to obtain more data from local citizens. And finally, we have this 3-dimensional twin, which is a more kind of a gamified environment visualization of one of the pilot areas. And we are developing this interactive environment because, well, in many cases you have local stakeholders that need to act on certain on data and make certain decisions. And what you then find is often they lack, well, really the technical expertise on a certain topic, and such 3-dimensional visualizations can then really help by, well, including the user in a sort of an interactive environment where they see the data in a different manner, and that can really help their understanding of, for example, different models. So in the project, this is how, for example, the 2D map interface looks, but we will focus now a bit on the 3D one. So yes, the 3D twin, we're really focusing on just one of the pilot areas because it takes a lot of time to develop this. So we are focusing on the one that's located near Barcelona, I think more specifically the Medes Islands in the Western Mediterranean. So we are developing the 3D twin using a game engine called Unity, and it's actually available via the browser. So it's easily accessible to anyone. The twin allows you to move around like you would in a game, so you can go up, down, underwater, move around above water, and it includes real-time information at the pilot site. So this is information on the water temperature, air temperature, whether there's rain at the site, the wind direction, etc. And also we're incorporating local assets such as different types of fish and corals that are relevant to that specific area. And what we're working on now is how we can visualize different climate scenarios having to do with, for example, heat waves, and then see what impact it has on the marine protected area. So you can, for example, see a shift in biodiversity. So you see more of the same species, or if you find different types of fish or corals, you can have invasive species that take over the MPA. So we're now seeing how we can implement that in the twin. So this is a screenshot of how it looks at night. So these are the Medes Islands that you see here, and at the horizon you see the coast of Barcelona. Underwater, we can find different types of species with some information. And here we see another one, but I made a short video that guides you through the environment a bit more. So this is let's say the 3D twin in the browser, so you can just access it. The first time you access it, it will take some time to load, and it's important to note that it's really still in development. So we have still, I think, 1.5 years left to improve, for example, the visuals and add more assets to the environment. But you see, you can just move around, you can go underwater, you can find information on, in this case, the Dentex species, which is native to the area. You see at the top there is a slider, so we're now looking at a certain time of year, and you're also able to go back in time about a month or so to see how the situation was at that time. So we just saw a dusky grouper, which is also often found in this region. Sea breams the same. So then, we can zoom out a bit, and you can also see at the bottom of the screen the current temperatures, and you see that if we go back in time using the slider at the top, you see the temperature change, you see the wind direction change, and also we have then some graphs that show the data at that specific area for the last month or so. So that's important to mention there. And then what we also see is coral types. So in this case, I think it's the Posidonia coral species, or the clavata in this case, which is also often found there. And then finally, we're still working out how we can best integrate these different types of scenarios. So working with local stakeholders that have done different analysis at the sites, for example, with heat waves, and then would be able to showcase different types of fish entering the environment if we look, for example, 20 years in the future. But this is still something to look forward to. I wanted to highlight the way we are building this twin. So each of these different, for example, fish species or corals, or the bathymetry, the topography, the sea level, the waves, how everything connects to one another, they're independently built structures, meaning that if you were, for example, wanting to make a similar 3D environment in a different area of the sea, for example, not focusing on the marine protected areas, but rather on wind turbines, for example, this is possible because each of these different components can be individually taken out without actually breaking one another. So the game objects, such as sea level, the waves, the way the user interface behaves, the mono behavior, how the character is moving around, they're all individual components that operate distinctively from one another, and that makes it really useful because then we can just build from scratch a environment in a different part of the world, and we can import parts of this twin that we think are useful, for example, the sea level, the waves, but also some other assets. And then we can also incorporate the behaviors of how they all link to one another. So that just makes it really time, let's say, efficient, because building this up from scratch takes a long time, but once you can actually reuse these components, it makes it also much more affordable, and also you can then focus more on the visuals and other parts that are important to convince stakeholders, and also looking on how, for example, you can include model outputs in the twin. So yeah, that's what we're working on in the Effective project, which is to be continued. Thanks.
Thank you, Dirk, for the lovely presentation on the Effective and the digital twins. And thank you also for keeping up perfectly with the timing of your presentation. We will now welcome Vesna Kuralt. She is the coordinator of the REMEDIES project, project manager, and a leader of corporate social responsibility and sustainable development. In addition to leading a Horizon Europe project with co-creating innovative solutions and technologies, she's experienced in co-designing various green and digital transition projects, which are focused on the human-centered innovation and community building, contributing to the sustainable development goals. She's also an anthropologist with a PhD in market communication, so she understands any change starts with people, and thus is passionate about creating a movement aiming to restore our oceans and waters. Vesna today will be talking about the project REMEDIES and the underwater drones to detect the Mediterranean Sea Basin Lighthouse. Vesna, the floor is yours.
Thank you. Thank you for this kind invitation as well. As said, I'm Vesna Kuralt. I'm the project manager of REMEDIES, and I'm going to be presenting a bit of what we do today. REMEDIES is one of the Mission Ocean projects. It's co-creating a plastic litter-free future. So it's not just about the detection, it's about much more. It's already towards the end of the project. We're in the implementation stage. We started already in December 2022, and we will finish end of the year, end of the next year. So what we're trying to achieve is to tackle the issue of plastic pollution with a holistic approach. So we are working within 3 pillars: detection and monitoring, collection and valorization, and of course prevention and zero waste. Because if we don't create as much waste and we don't let it leak into our environment, we have less of an issue on our hands. Very shortly, just briefly, that you see that we're doing much more than just the detection and monitoring, which is most of the solutions I'm going to be presenting today as requested. We are also working on collecting, both with the help with citizens, as like beach cleanups. Also, we have a river cleaning solution that's already stops waste entering the seas. We have microplastic filtration solution, and also prevention solutions such as zero waste natural cosmetic, biodegradable fish and gears, and bioplastic cups and bottles that are used at 2 different demo sites. One is a Greek beach bar, and the other one is one of the exit festivals. So there's a wide array of solutions that we are providing to actually fight the plastic pollution. So now, as mentioned, I'm going to focus on the environmental marine litter monitoring. Here, what is important is that we also integrate all of our solutions, and that the data then flows from the REMEDIES application into the portal, and then the impact dashboard that is displayed on the project website, or will be displayed there. What I'll be focusing today is 3 innovations: the AI-enabled aerial and underwater drones, the Shoreline Marine Litter app that is connected to the impact dashboard, and also a marine litter app for citizen science. And these innovations are implemented at the demo sites in Slovenia, Italy, Greece, France, Morocco, and Albania. And what is most important, they support the EU Marine Strategy Framework Directive and follow the EMUNET standards, which is very important for homogeneous standardization of data at the EU level. So first, a bit about the air drone monitoring. We are developing drones that are equipped with HD cameras and artificial intelligent algorithms. We have a picture here, a bit how it actually looks like. They are meant to detect and classify litter that is bigger than 2.5 centimeters on beaches and riverbanks. So it's not micro litter, but it's a bit bigger. And it can distinguish between plastic waste and other waste that is found on beaches. We are also developing an automated hotspot mapping with orthophotos and heat maps. And so far, by May, we have already auto-detected over 1,800 plastic items. So a bit for you to better understand about the key features of this technology. It's enhancing geolocation and mapping accuracy with high-resolution still images. And it has consistent coverage with pre-programmed flights with the drones, the DJI Pilot 2. And of course, what is most important is the machine learning models that can recognize and quantify plastic litter in images that are done. And of course, all of this data is then stored in our remedies portal and later submitted to the European Union repositories, namely EMONET. So our KPIs very shortly, it's going to be 100 flights across the 5 counted regions till the end of the project, and we will cover over 100 square kilometers of the shoreline. And there we will, of course, recognize and quantify all the plastic litter in images. And then also the underwater drone, which has a different aim. So this is an underwater remotely operated vehicle. We're using the Fish V6 Expert with 12 megapixel camera that also has a separate microplastic sampling unit installed. So we can do kind of two tests at the same time. So with the camera, we detect the big plastic debris on seafloor with the AI identification. And then with the separate sampling unit for microplastic, we collect water and then later analyze it in the laboratory. So here you can kind of see how it looks like in the middle picture. You have the drone, and then on top the sampling unit to detect for the microplastic sampling device. And then on the left, you have an image of how the integration looks like with the collection of the data with the app. So you can see kind of the surface where the underwater drone covered and where the data was collected, and then of course stored in our portal. And then on the right side, you have an image of how the FDRI analysis of filtered litter looks like. So here the KPI is a bit lower. We target 70 square kilometers in the Mediterranean Sea. The locations are the same. So far we have geotagged and documented 247 microplastic lead items on the bottom of the sea, and also filtered seawater with a recovery efficiency between 30 to 64% of microplastic in the filtrated water. And then last solution in terms of monitoring is the REMEDIES Shoreline Marine Litter app. It was developed using a REMEDIES protocol that was also developed within the project that is based on EMONET JLIS for sanitary litter identification. We are also distinguishing polymer type. So we check for PET, PP, and PE, and we mark it for each item while doing the monitoring. And we also use a near scanner to be more precise. How it is done is that we have 6 beaches in Italy, actually 2 of them, and then 1 in other countries, Slovenia, Albania, Greece, Morocco, and France. And then every season, meaning winter, spring, summer, autumn. We are using the same beach, the same 100 meters, where we monitor again for macroliter, for all items that are bigger than 2.5 centimeters. And then we are able to collect the data, provide it to EMONET, and then later use for research as well. And of course, everything is openly available for anyone else to do some research or compare some results. As mentioned, what is very important is the integration with EMONET standards for beach litter monitoring to achieve seamless reporting. We are also rigorous with the step-by-step data collection and validation workflow to ensure that actually all the data set is high quality. We support documentation with photographers of photos, which is mandatory, and support both beach seafloor with humans operators for the drones. And of course, provide the AI-driven detection and mapping, which is then used for advanced search filters using meta text and machine learning for errors reduction support with field validation. So in essence, what we're trying to do with all these activities is that we want to provide high quality of data that is then also submitted to EMONET. And this technology is also ready for integration with Editor. So the KPI is basically to have a smart repository and management of collected data, that these results are comparable with the standardized data that's collected in EU. And we track everything from the coordinates to date and time, number and type of the material as mentioned. We also do the top 20 lists of marine litter items for every monitoring, and we will then create a graph of waste by type by the end of the project. What we did on top of that is the REMEDIES marine litter app for citizen science, which is not something that we were required, but there was a need from the field. So we did a version of the app I just described that is using a more simplified protocol for the use of NGOs, for example, doing cleanups. So we are in this instance using the International Coastal Cleanup Protocol. How this came about is that we co-developed it with different NGOs that are already conducting cleanups around Europe. So last year, we collaborated with Čista Obala, with the Clean Coast in Slovenia, and then this summer with the Greek Eco Project, namely with the Blue Halkidiki cleanup that they did end of August. And then next year, we plan to validate the application with our partners, but we are also open to anyone who would want to test the application and adapt it for their own use. So we are open to give you support in that or adapt the app either by translation in your language or anything like that. And you can write to me if you are interested in such a collaboration. Here is also the QR codes to the application that is available on Google Play and App Store. So you're all very welcome to use it and give us any type of feedback. We have also developed a user guide that is available in different languages. And this is a very useful tool to engage either students or NGO volunteers or any other people that are interested in supporting collection of scientific data. And then last but not least, just that you have an idea that there's many things that we do in the project as well. So it's not just technologies and innovations. We do a lot of social events as well, citizen engagement and so on. We have organized a hackathon. We do a long list of cluster meetings. There's going to be one Monday again in Sardinia. We had open calls. We have artistic residences. and many other activities, because as mentioned at the beginning, we are trying to create a movement and work from different perspectives to kind of tackle the issue of plastic pollution. So only if we can come together and collaborate, we change our habits, we can actually co-create a plastic conscious society. So that's kind of our aim. So thank you so much, and I'm available for questions.
Thank you so much, Vesna, for showcasing remedies and the great work that you do with underwatering, ROV monitoring, aerial drones for environmental monitoring and litter detection, and also the Remedy Shoreline Marine Litter app. Yeah, any questions that you might have for Vesna, please put it in the chat. I see that some questions are incoming already, but yeah, we will have a brief session at the end to focus on those. Moving on, now we have a project iMermaid, and we have an expert talking about it, which is Jasmine Cicconi. She is an environmental chemist who works at the Research Center Department of the CMAT Group. SMAT manages the integrated water service of the metropolitan city of Turin, which is located in the northwest part of Italy, where she is responsible for catching and treating the drinking water, its distribution, then of the collection of resulting wastewater in the sewage system, and the subsequent treatment of that water. Last spring, SMAT held the first iMermaid project use case, during which the two technologies focused on heavy metal contamination in wastewater were tested. Today, Jasmine is going to talk to us about the sensor development for emerging contaminants and remediation platform solutions within iMermaid. Yeah, Jasmine, the floor is yours.
Thank you very much. Okay. Hi, I'm Jasmine Cicconi, and I'm from SMAT. We are part of the iMermaid project, which is a pretty big project with the consortium that is composed by 26 partners coming from 14 different regions of Europe and associated countries. In our project, we have to perform 5 different use cases, which are located in different regions of the nations. In particular,
to interrupt, we cannot see the presentation.
No,
no, just you.
Wow.
I thought it was just me, but can you try maybe?
Can you see it now?
Yes.
Oh, okay. Should start again? Or
yes.
Is it okay for you if I continue?
Yes, both is fine, however you prefer.
Okay. I can show you the first slide maybe with a photo of the consortium and the countries that are part of our project. As I was saying, in iMermaid we have 5 different use cases that will be deployed along Europe and not just Europe. Particular, the first one, treatment plant. The second one in Tunisia, in a wastewater treatment plant of a pharmaceutical industry. The third one, which is the one that SMAT is leader in a wastewater treatment plant focused on heavy metals. The fourth in Cyprus, in a buoy for the monitoring of the seawater. And last one in Crete, in Greece, that is for the monitoring of landfill leachates. In all of these different use cases, different technologies will be tested both for the monitoring and for the removal of contaminants of emerging concern. Today, I will focus on the use case number 3, where SMAT is the leader. Our use case is located in Brandizzo wastewater treatment plant, which is located in the north part of Italy, near Turin. Brandizzo wastewater treatment plant treats both industrial and domestic wastewater. Then, once treated, are released in the nearby river. The problem that we wanted to target with this use case is the fact that if high concentration of pollutants reach a wastewater treatment plant, they can be not removed removed completely by the wastewater treatment plant, and so they can be released into water bodies. So to solve this problem, a real-time monitoring technologies to remove with high efficiency these contaminants could be very helpful in addressing this problem. In our use case, we tested two different technologies. The first one is for the removal of three heavy metals, which are copper, zinc, and aluminum, that is developed by the Finnish startup Wefiner, and is called the 4D Scavenger. The second one is the heavy metal box developed by the University of Florence for the monitoring of four heavy metals, which are zinc, cadmium, lead, and copper. Regarding the first technology, the one for the removal of heavy metals, it has a lot of novelties. Among of them, the system can be completely controlled by remote. It has great automation, low maintenance activities, high removal efficiency, and selectivity for the target heavy metals. And the system has been also completely integrated with the second technology, which is the heavy metal box. The technology has been shipped inside a container from Finland, and the installation and the startup of the system took about 3 working days. Here we have the core of the technology, which is the 4D Scavenger filter. These filters, once the capacity is full, needs to be washed and regenerated through 2 different reagents that are stored inside the container. The first one is an acid reagent, and the second one is a basic reagent. Regarding the heavy metal box of the University of Florence, is equipped with a case in order to have an easy transportation if needed, and it is equipped with all the equipment for the catchment of the samples, sample pre-treatment, analysis, and dispose of the waste that is produced. The novelties of these technologies is the fact that the system is portable and can be integrated in other systems, such in this case, it has been integrated with the 4D Scavenger from the Finnish startup. It has a fast electrochemical technique that is able to measure in a few minutes 4 different heavy metals. The frequency of analysis is tunable and it can be controlled by remote. The waste production is very low, as it is the low reagents consumption, and the system has a detection limit that are below the low limits for the discharge of wastewater into surface water. Even if the pilot had a duration of 2 months between April and May 2025, we started a long time ago to prepare the use case. Indeed, we started in February 2024 for the definition of the best wastewater treatment plant managed by SMAT where to install the technologies. Then we performed some preliminary studies for the definition of the best installation point of the technologies inside the wastewater treatment plant, and we shipped also some samples to the technology provider to perform laboratory tests. Then we started with the site preparation that took from November 2024 to the end of March 2025, and then we had the deployment of the technologies. Here we have a description of all the treatment that wastewater undergoes in Brandizzo wastewater treatment plant. We start with a coarse screening for the removal of solids with biggest dimension, followed by a fine screening for the removal of smaller solids, at the oiling step, at the nitrification and the first oxidation stage, followed by a second oxidation stage, a sedimentation, and final step, which is the final disinfection with the addition of peracetic acid. We investigated 2 different points of installation, which are very different one from another. The first one is after fine screening, which is in the initial part of the treatment that wastewater undergoes, and the second one is in the last step before the discharge in the river, and is in the final disinfection tank. As you can imagine, the water qualities in these 2 different points of installation is very different. Indeed, after fine screening, we are at the beginning of the wastewater treatment, so we have higher concentration of solids and heavy metals, higher than the second point investigated, which is the final disinfection after the treatment, where we have lower concentration. What we have to take into account to define the best installation point was the requirements from the technological provider. Indeed, they required a wastewater that has a low total suspended solid content. To define the best point of installation, we had also to take into account the fact that the Finnish startup Wifiner developed a filtration system that was able to pre-treat the water before the pilot and to remove TSS content if this is below 20 ppm. So considering the average value of TSS content at the final disinfection tank that is well below the limit imposed by them, it is about 7 ppm, we defined that the best installation point was in the final disinfection tank. For the installation of the technologies, SMAT had to provide a crane to place the container in the Brandizzo plant, as you can see from the photo, electrical connection, well water. We had to purchase the reagents and equipment, prepare some solution in our laboratories that were needed for the heavy metal box calibration and maintenance activities, give on-site assistance to perform the maintenance activities and optimize the analytical protocol of the heavy metal box. And we also perform some sampling and subsequent analysis in our accredited lab in order to validate both the technologies. Since for both the technologies this was the first installation in real condition, we had a lot of challenges that we had to address. We can start from the challenges of the heavy metal box. Indeed, as soon as we connected the technologies to the electrical power, notice a high electrical noise that was caused by other instrumentation in the plant. What we did to overcome this problem was to change the pretreatment protocol of the sample, changing from buffer acetate to hydrochloric acid. You can see how the signal is very smooth pretreating the sample with hydrochloric acid, and also we grounded the instrument and we purchased a noise filter. In the first experimental setup, the water was pumped directly from the vessel, so from the technologies of the Finnish startup, the Furdy Scavenger, through a very long pipe. It was pumped to the heavy metal box, but using this setup, we experienced air bubble formation that caused a signal that was very noisy, and this prevented the analysis to be performed. So we purchased an additional tank and an additional peristaltic pump in order to let set the water for 2 hours prior to the analysis, in order to give time to the air that was dissolved in the water to be released in the atmosphere. With this setup, we were able to perform analysis for 3 of the 4 heavy metals targeted. As you can see from the left part, from the right part, we have a signal of copper in real samples of our wastewater. But to reach a good sensitivity for zinc measurements, we have to switch again the pretreatment protocol to the initial one that was with the acetate buffer, and in this way we perform also analysis of zinc. Regarding the second technology, the one for the removal of heavy metals, we perform daily and multi-daily sampling. We had to empty and fill the external tanks before and after the regeneration process. We have to give support on site before the regeneration process. We had to perform a periodical cleaning of the disinfection tank of the plant, and we also have to coordinate between the heavy metal box activities and the Furdy Scavenger activities. In the first period, we run the system just during daytime. Then in the second period, we perform also 24 hours run. The problem that we experienced, the issue that we experienced during the installation of these technologies, the fact that more regeneration cycles was necessary than foreseen. So we had to purchase also extra reagents that weren't foreseen based on laboratory tests. Here we have the results of both the technologies. In the left part, the results of the heavy metal box. In blue, we have the data coming from SMAT, from our accredited lab. They were compared to the data from the heavy metal box that are reported in green. As you can see, these results are very similar. So we can conclude that the heavy metal box gives us reliable results in terms of concentration. Moreover, the low limit that is imposed is 100 ppbs, and we were able to measure concentration that are 1 order of magnitude below the low limits. Indeed, we are measuring 10 ppbs in our samples. Regarding the third scavenger, you can see on the right diagram with the dotted line all the regeneration process that we had to perform. And in orange, the removal efficiency. As you can see, the removal efficiency were very high right after the regeneration process, but then they decreased. Right now, we are trying to understand with additional tests the reason of this decrease, and they could be related to high pressure related problems, and maybe a stronger filtration system was needed for these technologies. Last but not least, I would like just to introduce you one tool that was developed inside the iMermaid by another partner, the Italian company Softwater, which is the Aware platform. This platform is a cross-functional platform. This is the home page where you can see it contains all the use cases data. There is one dashboard for each use case, and each of these dashboard contains data coming from different sources, for example, sensor data, meteo data, laboratory data, and satellite-derived data. Available, there are two versions of this dashboard, a private one and a public one. The public one, you can see an example in the left panel, which is intended for the use of end user or citizens, and it doesn't contain sensitive data, while the private one is intended for the use of pilot area owners, such as SMAT for the use case 3, and it contains some sensitive data. Thank you. And if you have any question, I'm here.
Thank you, Jasmine, for presenting the iMermaid project, the portable systems, the different use cases, pilot installations, and also the platforms that you have. Our final project showcase for today is going to be presented by Pedro Fonseca. Pedro Fonseca is a professor and innovation manager at the Instituto Politécnico da Guarda. He holds a bachelor's degree in history and PhD in the history of science, technology, and scientific culture. Currently, he's pursuing a postdoctoral program in advanced digital technologies and the blue economy. He's also a project manager and the coordinator of ADT for Blue. And today he will be presenting ADT for Blue project and defining digital solutions for challenges in the blue economy using AI and IoT. So Pedro, go ahead.
Well, hello, good afternoon. Thank you, Josipa, for your kind introduction. I would like to say hello to everyone, all the participants and all my colleagues, especially to Berthe, Raquel Baral, and Sylvia Sebien, that are representatives of partners that build up this project, ADT for Blue, Advanced Digital Technologies for the Blue Economy. And before I start, as I was listening to my colleagues present, our project is somewhat different because we do not apply technology ourselves. So you'll see how technology is involved in the project, but it isn't the participants directly applying the technology in any kind of case study or prototype. So this project, Advanced Digital Technologies for the Blue Economy, is led by Guarda Polytechnic University, my university, and it is co-funded by Interreg Atlantic Area. Its budget slightly exceeds 3.1 million euros, and it brings together 13 partners, 11 full partners and 2 associated partners from the countries that make up the Interreg Atlantic Area, France, Ireland, Portugal, and Spain. You can see the logos of all the partners to your left hand side. And our purpose together, the purpose of the project, is to foster the digital transformation across the several sectors that make up the blue economy. So what are these advanced digital technologies? Well, mainly 3: blockchain, artificial intelligence, and IoT, Internet of Things. And we wish to foster their application, not randomly, not freely, but answering key challenges that stakeholders from the several sectors of the blue economy are facing within the Atlantic region. So our first step is to work closely with dozens of blue economy stakeholders so that we can identify real-world challenges that they are facing. These sectors include, of course, renewable energies, fisheries, blue food, coastal tourism, marine transport, logistics, and aquatic sports. So after we have had these workshops and work meetings with stakeholders from the blue economies within the Atlantic area region, we will integrate those challenges that we identified together with these stakeholders in the project's free open calls. So the open calls are, if you may allow the expression, the core business of the project. They're its main activities. And these open calls are directed, have as their target population, teams or individuals that will come up with tentative solutions to these problems through the application of one of these advanced digital technologies. So what we seek is to help them develop these pilot solutions, and we do that through a training program, an advanced training program that they can enroll in, through a one-on-one mentorship program, but also through several networking opportunities, including the opportunity to pitch their business ideas and their technological solutions to the appropriate audiences. So here we have the methodology with an additional key feature, but the one that I just described a while ago. So we map blue economy challenges here to the upper left corner. We then run the open calls and seek to establish interregional cooperation between those who are applying. Then the applicants that are successfully selected, and they are selected by external evaluators that are contracted by the team project. The ones that are selected will then have access to the training program, to the one-on-one mentorship, and to the networking opportunities to help them develop their solutions for the identified challenges. We will also help them, of course, to find further funding to further develop their proposals, and also to help them achieve the stage of go to market and get some initial customers. So outside the logic of or the mechanic of the open calls, we have several other activities and tasks, and one of them that is extremely important is the drafting of a strategic roadmap with recommendations for local decision makers, so local public authorities, regarding the adoption of advanced digital technologies within blue economy sectors. So who are the people that we are targeting? They are higher education students, researchers, alumni, that is former students, entrepreneurs, SMEs, startups, or blue economy domain experts, and also technologists. Of course, they could be here encompassed in the researchers, but also people that have a training and background in any of these advanced digital technologies, or just computation generally. So, as I mentioned, they will then apply their proposal to solve one of the identified real-world challenges. So we all have an idea of what the challenges faced by the blue economy are pollution, acidification, and so forth. But the challenges that we're identifying, with no disregard for what I just mentioned on those big general programs, are concrete issues faced by people that work every single day or almost every single day in activities related to the seas. So the project does bring this novelty to the table. That is, whoever is applying knows that they are trying to solve an issue that affects the performance of key players within the blue economy of the Interreg Atlantic area. As I mentioned, the applications are not evaluated by the team project. We have a board of an independent panel of experts that evaluate the proposals. So the training program consists of an innovative workshop on entrepreneurship, so that it explores the entrepreneurial mindset and helps the individuals and teams gain the necessary insights to what or how the market truly works. And it also includes customized training sessions. That is several modules, short, some from 4 to 5 hours, other from 40 to 50 hours on several subjects, from technologies to the business component to more issues related to teamwork and leadership and so forth. And there's also a one-on-one mentorship program. Before that, let's say that the workshop is mandatory, but then the training program is optional. So each team can choose from a large array of modules, which ones are better suited for the purpose of developing their answer to the challenge. They will then also benefit from a one-on-one mentorship program to help them transform their ideas into successful business ventures. Of course, this is particularly helpful because in such a process, those that are familiar with it, we do get to some deadlocks at any given point. So all this support is to help them develop and craft their innovative solutions. And after that, they will have, or during the process, they will also have access to several networking events within their regions, where they can, of course, that's what networking is all about, meet other key players, but also where they can, this is extremely important, where they can pitch their solutions. Of course, in the training program, they can learn how to pitch or gain some further insights for those that already have some experience, and they can also receive some advice from the mentors, and they will also at a final stage receive support to continue their voyage after the project has finished, and that will happen next year around August, so that afterwards they can continue their journey and further develop their innovative idea and others with public and private funding initiatives, but also through the normal functioning of the market, which means, of course, having customers. So Open Call 2 is currently closed. So the external evaluators are at this moment conducting the examination of the proposals. It closed in early August, and the Open Call 2 had 11 challenges from 8 different blue economy domains, and it looked to select 30 innovative ideas. We received almost double applications. So these are the domains that were part of OpenCall 2: aquaculture and fisheries, communication, maritime transports, port activities, ocean monitoring, conservation, and marine ecosystems protection, also coastal and tourism solutions, data analytics, and finally, ocean renewable energies. As for OpenCall 3, that will be launched this month on the 29th, it will have, well, this is what is foreseen. We still have a couple of more meetings to ultimate all the final details. But if it were to be launched today, it would have 15 challenges from 8 Blue Economy domains. And we would also be looking to select another 30 innovative ideas. So just to give you, before I close up, and I think I'm still within my time frame, just to give you an idea what kind of challenges we have been identifying. I bring you 2 that will be a part of OpenCall 3. One from the shipping and repair domain, and another one from the ocean monitoring, conservation, and marine ecosystems domain. So the first, the challenge is to find a way to reduce biofouling. That's what you can see on the ship there. So that's living organisms that tend to stick themselves to the ships, and this brings a lot of damage, not only by themselves, but because the existing methods to clean the ships are themselves highly polluted and highly damaging for the ship itself. It has, of course, also brings also biodiversity issues, because it transports marine life from one place to another. Some of those organisms will then behave as biological invaders and bring in a lot of harm to the equilibrium of the ecosystems, but it also makes the ships heavier, which means that they will have to use more fuel to move around. So this is the problem that was identified, and now we will turn the challenge public and see what potential solutions appear through the applicants. Of course, the solution has to be based on one of the advanced digital technologies that we mentioned. It doesn't have to be a rocket science breakthrough. It can perfectly be an already existing application of technology, but have it applied into a new context, applied to solve a new challenge. The other one, and I will just conclude, is to provide coastal fishing communities. Here we have an AI-generated representative of the coastal communities to allow them to have access to important data concerning their fishing activities. That would be for them to be able to know in due time how the weather will be in the areas where they are going to fish, but also to know about any kind of movements of the fish that they are looking for, and also to be informed about the market prices of different kinds of fish, so their activity can be more profitable. So I hope I stayed within the time frame. Thank you very much for your attention.
Thank you, Pedro, for showcasing ADT for Blue. It's open calls, mentoring and training programs within the open call, and then also the news on the upcoming open call 3. We are actually a bit over time, but still I want to thank to all of the project representatives for the fantastic showcases of their projects. It's very clear that the future of maritime monitoring and protection really relies heavily on this kind of level of cross-sector technological synergy. We were supposed to open the floor for questions, but Patricia, I believe we don't have enough time to do so. We've had questions asked in the Q&A, and kindly our panelists have already answered those. There were 2 additional questions, but unfortunately our panelists for AUTOASSESS and for I-SEAMORE, they had to leave a bit earlier. Nevertheless, we'll get them to answer the questions for you and then hopefully send them in the wrap-up email. Since we're gonna close soon and we don't have enough time to do a proper Q&A, I want to say that, yeah, this brings us to the end of our session. A very, very big thank you to all of the panelists, all of the speakers for sharing such valuable insights and concrete solutions within their projects. Also, a special thank you to our co-organizers, the entire Blue Mission AA team, for their incredible work in bringing these kind of webinars to life. I also want to thank my F6S team for co-organizing this alongside with me, and also for our audience. Thank you for joining us today. Please make sure to take a look at the chat, and there you can see the links to some of our projects. Please follow along on all of our participating projects on LinkedIn, their websites, as well as the Blue Mission team and the F6S team, in order to stay updated on these crucial advancements. There is a next Atlantic and Arctic Lighthouse Weekly Hour webinar coming up, and I'll ask Anna just to briefly share about it before we wrap up.
Thank you, Josipa. Thank you to all the speakers, and thank you to everyone who joined online. This was a really intense webinar with lots of new solutions that were presented, and I congratulate everyone for these innovative solutions. I think they really have so much potential to upscale our efforts to protect our ocean and waters. So yes, I will pick up on Josipa a last minute note regarding the next weekly hour hosted by the Blue Mission AA. It's going to be in about 2 weeks, and it's going to be dedicated to digital tools for citizen science and monitoring. So we'll keep the topic of digital solutions. So thank you, everyone, and have a nice day.
Thank you all.
Bye.
Thank you.
Thank you.
Bye-bye.
Bye.
Bye-bye.